Hello and welcome to the Institution of Analysts and Programmers webinar on artificial intelligence. The rapid expansion of AI has transformed the way we work, live, and interact with technology. The ability to interact with AI will soon be as essential as using a mobile phone, browsing the internet, or sending an email. As AI becomes increasingly integral to our daily lives, it's essential to address concerns about accessibility, affordability, and data privacy. Current AI solutions are often proprietary, expensive, and cloud-based, requiring users to share sensitive data in exchange for access. This raises significant concerns about data privacy, security, and ownership. Moreover, the reliance on cloud services can limit the flexibility and autonomy of individuals and organizations. This webinar aims to challenge this narrative by demonstrating that one can have a cost-effective, potent, locally hosted AI solution for various purposes such as work, education, research, or experimentation. The installation process is straightforward, taking less than 15 minutes. Use cases and examples of prompting the AI are provided, showcasing its ease of use and potential applications. This approach not only democratizes access to AI, but also encourages a more profound understanding of its capabilities and limitations. By fostering a dialogue around the ethical implications of AI, this webinar aims to empower individuals to make informed decisions about their engagement with AI technologies. Today's host is Rolfe. Andrew is a seasoned professional with over 4 decades of experience in commercial programming across 23 languages, 19 operating systems, and 12 architectures. His extensive background includes working on everything from mainframes to smartcards, making him well versed in both traditional and modern technologies. He's a long-time Debian Linux user, for over 2 decades in fact, and Andrew brings a unique blend of passion for programming, open source software, arcane Unix tools, and the Vim editor. He is also known for creating his own programming language, Mia, a trifling of a program language, and runs a retro open source project called Wolfmud. Currently, Andrew's employed by ai4all, a consultancy that has been developing smart business processes backed by AI since 2019. Andrew brings practical experience and insights to this webinar, and his expertise in both traditional and modern technologies ensures that he can provide a valuable perspective on how AI is evolving and how it can be effectively utilized. Andrew, over to you.
Good afternoon, everyone. Welcome to AI4all. The computer industry is more hyped up on AI today than a toddler on a sugar rush. Billions of pounds are being invested in this transformative technology. AI has the potential to revolutionize countless industries and aspects of our lives. The future of AI remains open and exciting. As smarter systems are developed, it's important to focus on creating an ethical and beneficial world powered by AI. I want to show that AI can be accessible to everybody. Everyone here can have easy access to a safe, non-technical, private and powerful AI on your computer at no cost. Your own personal AI for work, learning, experimenting, or simply to satisfy your own curiosity. Before we go on, a little advice and a few words of caution. AIs can be a powerful tool, but they are not infallible. They make mistakes, they can hallucinate, and they can make up convincing sounding facts. For this reason, an AI should not be used as a replacement for professional advice. Generated content should not be blindly accepted and trusted. You should obtain consent for any data sent to an AI. If the AI is offered as a service, you cannot control what happens to your data. This should be brought in mind when using tools like OpenAI's ChatGPT, Microsoft's Copilot, or Google's Gemini. If you're using an AI, then you should disclose its use when appropriate. Most of all, AI should be used responsibly and ethically. Now, a few basic concepts. Artificial intelligence is the umbrella field of the study of machines and devices that exhibit human-like reasoning qualities. Machine learning is how an AI is created. We no longer program AI systems, we teach them. The large language models are the distilled results of machine learning. They allow us to distribute a pre-trained AI. How a model is trained determines the AI's areas of expertise. For example, a model could be trained on general knowledge, on science, medicine, or on source code. Generative AI is a form of AI that uses the large language models to create new derived works from existing data. When we're interacting with an AI, we write prompts. Prompts can be in the form of questions or instructions guiding the AI to produce a specific response. This is a very simple example of such a prompt. It's an instruction asking the AI to create 3 haiku. When prompted, the AI responds with 3 haiku. We'll get back to some more interesting prompts very shortly. Getting started in AI is difficult, intimidating, and expensive. Every vendor has their own toolkit and APIs for talking to their AI. Vendors typically charge based on the number of input and output tokens. For simplicity, a token can be thought of as a word of text. If you're running a public service or repeatedly doing unit testing or integration testing, the number of tokens used soon mount up. If you want to create your own AI instead, then training an AI to create a model becomes prohibitively expensive. You need large quantities of good training data and the compute power to be able to crunch the data. Often the only option left to you is to use pre-trained third-party models which have their own issues. Often you don't know what data they are trained on, what safeguards were in place for the training, or if the training data was biased or censored in some way. Now, I've been working with Google's Gemini AI a lot, but I wanted to have my own AI for running examples and experimenting. From this itch to have my own AI, I drew up a wish list of features I wanted. I wanted an AI that I could run on my own hardware, mostly old hardware, not very powerful hardware. I wanted to be able to use the AI as much as I wanted and not be charged by the number of tokens I was generating or using. But I also wanted the AI to be easy to interact with, and I wanted to be able to easily integrate it into my own software. But the AI should also have high quality models available that I could use from the likes of Google, IBM, Meta, etc. But I wanted the AI to be private. I didn't want to share all of my data with some service that's hidden somewhere in the cloud. But the AI shouldn't be just a toy. I wanted to use it for real work, for learning, and for experimentation. But I also wanted it to be easy to set up so that I could show people that an AI could be used on their own systems very quickly and very easily. That was all I wanted. Very short, simple wish list. And my wish was granted. Ollama is an open source project that makes it very easy to have your own powerful AI. It makes interacting with an AI simple and allows you to switch easily between different models. For Windows, Linux, and Mac users, a simple download link is provided on the Ollama homepage. You just click to download the installer, click on the installer once it's downloaded, and run it. And that is the entire installation process. You now have an AI on your machine. You can also do simple manual installations. This is useful if you're running Linux or if you want to run it in virtual machines or in containers. You can do manual installation by simply creating a directory for Ollama, downloading the software, unpacking the software, changing into the binary directory that's created for you, and then just simply starting the server. If you have very specific security, compliance, or auditing requirements, you can download all of the Ollama source code, examine it, audit it, put it under version control, you can integrate it into your CI/CD pipelines, and you can compile everything yourself. Now, to use Ollama, I'm going to show examples using a terminal. However, graphical interfaces are available. For the terminal, you change to the binary directory. The first time you use Ollama, you pull a model that you want to use. In this case, I'm pulling the lava model, which also has vision components for doing image analysis. And then you tell Ollama to run with that particular model. And straight away, you can start talking to the AI. Here, I'm just saying hi and get a response. Now, there are other models available. Some of the more notable commercial friendly ones are Gemini from Google, 5 from Microsoft. We've got models from IBM, Meta, Mistral, and Alibaba. Another thing to know is if you install Ollama, when you're not using it after a period of time, which is 5 minutes by default, all of the models it's using will be unloaded from memory, and Ollama will just quietly sit in the background, not using any resources at all. But what can you do with Ollama? With Ollama, you can have a chat session, just as you would with GPT or Gemini. You can ask questions and get answers from it. You can use it to generate text for emails, messages, project outlines, and you can perform image analysis. You can ask it what is in an image. You can ask it to extract text from an image. And you can use it to categorize and summarize text as well. You can use it to determine the intent and sentiment of a user from the prompt that they're providing. And you can use it to translate text. Some of the models available understand over 21 different languages. And you can also use Ollama to query closed domains. If you have an insurance document, or if you have a manual or a handbook, for example, you can effectively chat to your documents and ask questions about the content. And this is just skimming the surface of Ollama, just so that I can fit it in this afternoon. As I said earlier, you interact with an AI by writing prompts. We've seen an example of a prompt already. Write 3 haiku about AI. The skill of writing prompts is called prompt engineering and is a large specialist topic in itself. There's a very good guide at the link provided in the middle of this slide, promptingguide.ai. Just as using a mobile phone, writing an email, or using a web browser have become commonplace, interacting with AI will also become commonplace. For casual use, you can chat with an AI, post questions, and get responses. However, to get the most out of an AI, you need to know how to prompt it correctly. I'm going to show some of the capabilities of Alarma through some example prompts. The prompts are not Alarma specific and should work for most AIs. I'll be going through the examples quite rapidly. However, handouts will be available at the end so that you can examine the prompts and output in more detail, and you can try them out on your own copy of Alarma or other AI. Now, starting off with a very simple example, here we're prompting the AI to write an email asking for some annual leave. The AI responds with an email template that we can cut and paste into our email client. In this example, we're prompting the AI with information about a new product, and we're providing some contact details. We want the AI to write a sales email to a customer announcing the new product. The AI responds with a nice sales email ready to be cut and pasted. It has all of the product details and features, the contact information, and links for the website and email address. What if we take the same product information and contact details, but this time prompt the AI to write a product announcement? In this prompt, only the last line has been modified. The AI responds with a product announcement with all of the relevant details ready to be cut and pasted into a CMS or posted to a social media platform. Now, here we're prompting the AI to create an outline for a presentation covering some specific topics. I didn't do it for this presentation. This is literally just an example. The AI responds with a complete outline for a presentation, complete with suggestions for content that can be included. Now, we're all time poor and would love to read all of the interesting articles that come our way. What if we save time by asking the AI to summarize those articles for us into a few bullet points? Here's an example from an article on quantum computers. We ask the AI to summarize the article into some bullet points. The AI responds with a summary in 4 bullet points, covering all of the main points from the original text. Here we have a more complex example. It's a chat conversation between a customer and a support agent. Prompt the AI with the chat history and ask it to provide a summary of the conversation and to generate a list of tasks for the support agent based on what is discussed. The AI responds with a summary and a list of to-dos. As we'll see later, this can be produced as a JSON response. Combined with REST APIs or agentic AI, it would be possible to automatically update a CRM or to raise the to-dos as actionable items. In this example, we have an image of a backpack on a trail. We prompt the AI to generate a title, a caption, and a description for the image, something that could be useful if you need to populate a large product catalog, for example. And the AI responds with a suitable title, caption, and description as expected. Here we have an example of translation. We have 3 messages written in different languages, and we prompt the AI to list the original message, the language the message is written in, and a translation. And the AI responds with 3 translations with the original message, the language that it's detected, and the translation itself. Now here we have a different type of prompt. We want the AI to determine the sentiment of film reviews. This prompt has 3 examples of film reviews showing the AI how we expect it to respond to us. At the end of the prompt, we pose our own review. It was too long, too dark, and the acting was bad. And with an empty output for the AI to fill in. The AI responds with, a single word sentiment, as that is all we asked for. In this example, we have requests from 3 users. For each request, we prompt the AI to determine the user's intent. This can be useful for directing a user to an appropriate service or area of a website, for example. The AI responds with, the first user is looking to make a reservation. The second user is trying to place a food order. And the third user is looking for information or product knowledge. Now, this prompt is the most complex example I have today. It contains details about a product, in this case, a teddy bear, and a list of customer reviews and comments. We prompt the AI to perform 4 specific tasks: to create a product description, extract the product specifications, to summarize what customers think of the product, and to determine the overall customer sentiment of the product. The AI responds with a summary description, the extracted product specifications. There's also a summary of how customers feel about the product based on the reviews. And finally, there is the overall sentiment of customers of the product. What is of particular interest here is the summary of how customers feel. The AI has picked up on the fact that some customers would prefer a smaller or larger version of the product. Sounds to me like a good sales opportunity. Now, we just saw an example of a complex prompt. What about a prompt that produces complex output, where the AI can really start to show off? Maybe get it to do a little research for us. I've been musing over the implications of AI coming together with quantum computing. They are both grounded in probabilities and seem to be a natural fit for each other. The top of this slide shows the prompt I use to produce a research paper on this topic. The bottom of the slide shows the processing steps I performed. We run Olama with the prompt as input and generate a markdown file. We feed the markdown into a processor and generate HTML. There's some very minimal light editing, and then we open the HTML in a browser and save it as a PDF. In all, we're looking at about 10 minutes work, including waiting for the AI to do its magic. What does the PDF look like? We get a 2-page beauty. The screenshot is a little blurry. The original PDF isn't. I've checked the content and it seems very reasonable. And when the model was built, the links were valid. However, many are now broken and out of date. The PDF original will be available as a handout at the end for those who are interested in taking a close look at it. Now, as well as prompting an AI through a chat-like interface, we can interact with the AI programmatically using REST APIs. This example is a bash script. It makes a HTTP post request to prompt the AI with the translation example we saw earlier, here shown in blue. The response is then formatted using some standard tools before being displayed. Using the REST API, any application or programming language that can make a HTTP post request can integrate with and make full use of the AI's capabilities. When run, this script produces our translated messages, the same as we saw earlier. However, this time, the prompt is sent programmatically to the AI as a post request using the REST API. All of the examples so far have been static and baked into the presentation. The question then is, does this all really work? Is it really as simple as I'm making out? Time for a live demo. Right, I hope everybody can see that. I've tried to make the text as large as I can. This is a list of all of the AI models that I've currently got available on my machine. At the moment, it's clocking in at about 100 gigabytes of data. Now, what I will do here is I will start Olama at the chat interface. Here I'm using the Gemma 2 model from Google, and I can say hi, and it responds with hello. Now, let's ask a question. And here I'm just asking it, what are the primary colors if you're using pigments? And it responds red, yellow, and blue. Now, because I'm in the chat interface, the AI has access to the context of the questions that are being asked. So I can continue this conversation and ask it, what are the primary colors for light? And it knows I'm talking about primary colors because of the previous question. So for light, we get the answer red, green, and blue. Now, we can also have multi-line prompts. So if I use 3 double quotes, that goes into multi-line mode, and we can ask both those questions together. And this is useful if you're cutting and pasting text that you want the AI to work with. For example, if you're cutting and pasting from a document, or if you're cutting and pasting from an email. So here I end the prompt with 3 double quotes again, and this time it answers both of the questions one after the other. Now, that's one way of being able to interact with the AI. If I exit that, what I can also do is I can pass the prompt directly into the AI from the command line, like that. And the difference here is if I try to continue that conversation, it doesn't know the context if I say and for light, because when you're passing the question directly on the command line, the session ends when you're returned to the command line. So here, this is actually 2 different conversations, and it doesn't realize that I'd already asked it a previous question. Now, one of the other things we can do is we can put our prompts into a text file. Here I've got the teddy bear product review prompt, and it is held literally as plain text in a text file. And what that allows me to do is I can take the AI and I can just feed the text file directly into the AI. And here it's generating the product description and summaries again. Now, the advantage of this is that it's testable, it's reusable, it's repeatable, and we can version control and back up the prompts as well. Now, I have another prompt here, which is this is the image generation example. And this time, the interesting thing of note is that we're actually asking it to produce the response as a JSON file. So if I quickly run that, and this time I'm going to switch to the Lava model, which has the image processing components. Image analysis takes a little longer than generating text. And there we have our response as a JSON file. Now, another example that I've got here is the REST API example. So this is the bash script that we saw earlier. And if I run that, we're now sending our request to the AI as JSON and getting the response. Now, if we can interact with the AI using a REST API to send JSON, and we can get the results back from the AI as JSON, we can start using this to put together our own tools and our own services. Now, one such tool I've been working on is the litany of refutable evidence, or law for short. And if I just start this running, because it takes a little while, here I'm going to ask law to describe Pythagoras' theorem and to give us the equation for it. Now, what we have here is we're giving the same prompt to 5 different AIs, and each one is going to respond. And we're going to collect each of those 5 responses, and we're going to give it to another AI that's going to act as a moderator, and it is going to form a consensus over all of the results that it's had returned to it. And the point of this is, if you're doing research using AI, you've still got the problems of AIs that hallucinate and lie to you. By asking multiple AIs and receiving a consensus, we can actually compare the responses that we're getting back. And if we have an AI that decides to go rogue, normally in this example, it's Tiny Llama, which is a very small model, and it usually answers the wrong question. So we've got the consensus here. We've got what the Pythagoras theorem is. We've got the expression coming out, the formula, and it also tells us which information is coming from which sources, and it should say, yeah, here, source 2 seems to misconstrue the theorem, and it's basically telling us that Tiny Llama has gone rogue and it's providing inaccurate and possibly misleading information. So if I was running this and doing research, I typically use more than 5 AIs. Typically, this would be run with between 10 and 20 different AIs. But for this presentation, I reduced the runtime for it. But this is a way that we can use multiple AIs to try and cut down on misinformation, on hallucinating AIs, and have results that we're pretty confident in the answers we're getting. Now I have one more demo to run. I just need to switch to my other browser. So this is a simple service that I've written using the AI, and I can pick an image, nice festive Christmas image, and I can hit generate, and this will now ask the AI to generate the title, a caption, a description, and some hashtags for the image that I just uploaded. And if I pick my Halloween, because that was when this presentation was originally written. There we go. And if we, because it's generative AI, we can take the same image and generate it again, and we should get a totally different response. There we go. And we've also got the backpack example from before. Got title, we've got the caption, and we've got a description with our hashtags generated for us. Now, if I go back to the presentation. So, I think we can safely say that Olama does do what it says on the tin. Now, the machine used for the demos is a tiny 1 litre PC. It uses an older low power workstation graphics card, and an older generation CPU. Alarma can achieve much better performance using cheap, popular gaming graphics cards. At the moment, Nvidia and AMD are very well supported. Soon, Vulkan will be available in Alarma and cover a much larger range of graphics cards, including laptops with built-in graphics. If a suitable GPU is not available, then Alarma can still be used and will just use a CPU for all of its processing. Now, Alarma can be run on systems with very limited resources. I've had it running smaller AI models generating 6 to 12 tokens a second on an 8 gig Raspberry Pi 4, which retails for about £70. Performance was comparable to a fast reading speed, but it was usable and adequate for experimenting. At the other end of the spectrum, Ollama can be used to create large commercial AI servers, either in the cloud or on-prem, with multiple GPUs, copious amounts of memory, and a vast array of different AI models that can be used. Now, that brings us to the end of the presentation. Installing Ollama is very, very easy, as is using it. I encourage everybody here to try it out for themselves. As I said, PDF for the presentation will be available shortly in the chat with all of the examples included. Thank you for your time. Do we have any questions?
Yes, I have a question, Andrew. That was a fantastic presentation, a real eye-opener, and it's amazing of the diverse sort of tasks that it can carry out. I've got two little questions, really. The first one: what language is Ollama written in?
Um, Ollama itself is mainly written in Go. However, it piggybacks off of another project called llama.cpp, which is written in C++.
Okay. And the second part of the question was, we're talking about different models and actually even using them to get consensus. As I understand it, it's not going to the cloud to get those models. It's storing a snapshot of those models in the LLM.
Everything is local on the machine where you install Ollama. Ollama, by default, unless you code your own services that integrate and then go out to the internet, for example, Ollama will never retrieve information from outside of the local machine. So all of the models that I was using there, I have installed on my PC here.
Okay,
So
and can you use like a get command to get a latest snapshot of a particular model?
yes, if you do the Ollama pull command with the
Yeah.
model name, then it will either pull down the model if it's new, and it will update the model if it's been updated in the Ollama library. You can also pull models from a service called Hugging Face, which is a bit like uh, GitHub for AI models.
Great. Excellent. Okay, have we got any questions for Andrew? John?
Yeah, it's more of a comment because I know Andrew and I have spoken about this before, and I think first off is obviously the fact that it's self-contained, and literally, when we first discussed this, I was quite amazed and literally just pulled the leads out of the network once I'd installed it, and it just ran. And you look at the size of it, and the actual. I know the ones you've got there was about 100 gigs for all of your models you have there.
Yes, yes.
So the actual model for Ollama just on its own is quite small, and you look at it and you think it's not quite the sum of all human knowledge, but all the questions you can ask are coming out of it, and it's just self-contained. And I found that personally mind-blowing. And I know I use ChatGPT and Llama and Gemini, etc. And the things that it's doing and getting better at each time they do it, the libraries are getting bigger and better, and the actual underlying code is being updated. I just find amazing. I've just written some code, quite a lot of code for a plugin for WordPress, and it would have taken me, I think, say 3 or 4 weeks to have written everything, and I've probably done 80% of it in about 3 days using code generator tools that are there. I would say you do have to check, because it doesn't necessarily code the way I would code, but equally you do learn different ways to do things as well.
Yeah, I think with most of the models that I work with and the models that you were using, John, they're typically between 2 and 5 gig in size. And even those models, which are sort of like the medium models, are very, very capable for what they can do. It's like one of the models, which is about 5 gig, um, can respond to you in 21 different languages. Which is amazing for the size of the model.
It is. It's very mind-blowing.
One of the things I will say is with Olama, it is very capable as an AI. It's continually being worked on and improved on, as with the Vulkan drivers that are going to be added soon. And it is perfectly usable either locally as a private AI on your own machine, but you can also create business solutions with it. You can create enterprise solutions with it, and it will scale, as I said before, from a simple tiny Raspberry Pi right up to massive servers with a large number of CPUs and GPUs. So yeah, it is a viable alternative to things like a commercial ChatGPT license for a private instance, for example.
Okay, Andrew, Dinesh Chako's asked, have you downloaded and run AI models from Hugging Face on your machine?
Yes, I have. There is now a feature which has been added to Hugging Face where the models are being updated, and when you click on the download link for a particular model, you can actually select an option for Olama. That's the easiest way. If not, the Olama website does have instructions for how you can convert a Hugging Face model to a model that Olama understands. The hardest part is knowing how to create the correct template for Olama to be able to use the model.
Right. Have you tried a voice sort of interface to the model and try to interact it by speaking?
I haven't used models that are specifically tuned for that. However, Olama does work very well with um, standard speech-to-text software as you might use for assistive technologies, and you can also use things like the Festival or Flight software, which will go the other way and it will turn text into voice. So you can actually have a conversation with the AI and get it to speak back to you. So, but
Great.
at the moment, that is putting tools around Olama rather than everything happening in the AI
Yeah,
itself.
yeah. Nicholas has a question for you. Sorry, audio not working.
Okay, if he wants to put his question in the chat,
Yeah,
that's fine. I can
yeah,
still answer it. Right. In answer to the specification for running the models there, um, typically with the models, you need 1 GB of memory per billion parameters. So, for example, if you're running a model that has 8 billion parameters, it would take 8 gig. If you're running a 32 billion parameter model, then you'd use 32 gig. However, within the last 24 hours, Olama now has a feature where you can reduce the quantization used within the Olama processing, which can either half or reduce down to a third the memory requirements. So you can take a 9 billion parameter model and either run it as 4.5 gig or 3 gigs, um, depending on how much accuracy in the response you're willing to lose. So the model is still quite accurate if you half the memory requirements, and a little less accurate if you really reduce the memory requirements. I think that answers this question. Nicholas,
Yeah, what is a model and who constructs these?
right, when you're creating an AI, you give it vast amounts of training data, and that training data is used to tune the parameters for an AI. So, for example, a typical AI might have 8 billion parameters, or it might have 16 billion parameters. And basically, these are just values that are set randomly when you start the training. And then as more and more training data is fed into the AI, these parameters are tuned so that based on what data is coming in, it influences the response that's generated. Um, that training is typically done by the big companies. For instance, Google, Meta, IBM, OpenAI. Uh, just to give you a sense of what's required to train a model, ChatGPT 4 took something like, um, I think it was nearly $100 million to train it using um, literally terabytes of plain text. I think it was something like 16 trillion tokens were fed into the model to train it.
Wow.
Um, so it's a huge investment to create these models. Um, Typically, what people will do is something that's called fine tuning, where you can take a model that somebody's spent all of this effort generating, and then you can sort of put a layer over it that has your private data, or you're training it for a very, very specific task. So, for example, you could take um, Meta's Llama model, which is a general model, and then you could give it additional training data to fine tune it to be a medical expert or a lawyer, for example.
I think John's got a question.
Yeah, I was going to say, Andrew, because we're talking about these models. Do you think that obviously large language models have only been around for a few years now compared to the previous attempts at AI, which have obviously been swept aside? Do you think we run a risk of having too many models being created by too many companies doing the same thing? And what do you think the future will be? Do you think we'll end up with just 2 or 3 companies making them? Or do you think we'll continue as we are with models appearing from everywhere?
I think that we're going to have models that are specifically tuned for specific specialities. So, for example, you might have a model that's particularly good at writing poetry, or it could be particularly good at fraud detection or generating code in a particular language or doing language translation. So I think what we will end up with more of is what they call a mixture of experts, where you have an AI, and depending on what you ask it, it will then pick an appropriate model to answer your question. I think that we will start to see a lot more of that.
Yeah, thanks.
There's a question which I think is from Nicholas, asking about models and CLI and REST endpoints and things. Olama runs in two different modes. When you start Olama with the serve parameter, it will start Olama running in the background so that it can answer the questions. You've then got the client side of it, which is where you can have the chat interface and you're talking to the server that's running in the background. Now, the background server can also act, it has all of the endpoints which are only accessible locally on your machine. So the server will provide all the processing, it'll hold the models, it'll provide the REST endpoints. And then separately, you've also got the chat interface, which was the CLI that I was using during demonstrations. So everything is contained in the one download that you install.
Yeah, I think Dinesh has got another one there for you, Andrew. On
Just to answer
SQL.
Luke, yes. Luke was asking, will we have a model to select the best model to answer us? And I think that is where all of the multiple models will go. What was the other question?
Dinesh, do you, if you do a sequel to the presentation, please download a model from Hugging Face and run it on your machine.
This is actually quite an interesting question, because I was thinking of doing another webinar that expands on what I've done today, some of the more advanced techniques, RAG solutions, which is a common way of being able to query a document database and things. Maybe touch on things like ChromaDB, which is a vector store commonly used with AI. I'm just wondering if we can have a show of hands to see if people would be interested in a more advanced presentation.
Yeah, I'll be up for that.
I think there is some interest then.
Yeah,
I'll have to see what I can put together.
Yes, I think so. I think that looks good. Yeah, I agree with. I think this is an eye opener. It's sort of sparked a thing in me. I want to go and have a look at this myself.
You should do it. It's very easy, very simple, and you'll have your own personal AI to do your bidding.
Paul, I think it took me 5 minutes to download Olama onto my Windows PC, and it literally just ran.
Wow.
I would say it ate 100% of my machine in about 2 milliseconds, but when it's not doing anything, I think Andrew said it goes back to sleep and just sits there. So it's well worth a go.
Okay, I think Andy's got a question.
Not really. I was just making a comment now.
Okay.
I'm making him out of retirement.
No problem. Are there any more questions? Just one last time, just to check. If not, no. Okay. Well, thank you very much, Andrew. That has been a real eye-opener. I found that fantastic. I mean, your examples were absolutely brilliant, and it just shows how flexible this this piece of software is. And I will, in the next few days, try this out myself. And it takes a lot to get me inspired these days to try something new. So you've worked a wonder. Just to say thank you very much, and thank you all for attending and taking part. and we will arrange for 2 handouts to be emailed out to the attendees. And at some point, I know it's taken us a while these days, but at some point this will go up on our YouTube channel, and you'll be able to catch up with it there. Okay, thank you, Andrew, and thank you everybody, and we'll bring this meeting to a close, and hope to see you at our next webinar, which will be sometime in the new year. And in the meantime, we wish you a very Merry Christmas and a prosperous New Year.